Okay, so what does this problem say? Two particles or masses or spheres of charge Q and what? Q and. So all we know is that one of them is how much of the other? Twice the charge. But one of them is what? Negative, and one of them is? Okay, good. Are placed or located as shown in figure 6. Sorry, here is figure 6. There we go. A third charge, Q what? Q3 is placed on the x-axis to the left of Q. So to the left of this one. So where is it going to be? Right here, exactly, on this left side. The total electric force on Q3 is how much? Okay, everyone, let's think about this for a second. Okay, if you have, so are those charges moving or not? What do you think? No. The third charge, is it moving? Yes, it is. Because whatever you add to the system to test it, you call that what? What do we call it? Test charge. Okay? Question for you. If I put it here, and by the way, the test charge could be any charge you want, but usually it's what? The test charge is usually what? Positive. We'll know why usually it is positive next week. But for today, just always know it's positive. Everyone, if I put a positive charge here, listen up. Again, no math, just concept. You put a positive charge here. Actually, I'm going to put it. Okay. All right. Put a positive charge here. Now, this is positive. This is also what? And this is the only one that could move. So under the influence of this one, what is the only way this could be moved? Which way? Tell me how to move my hand, right or left? The only way that this could be moved, if it's positive, with this one positive, if this one can't move, is what? This way. Okay, let's bring it back in. Now let's imagine this one doesn't exist. And now I talk about this one. How would this one influence this one? The only way. Move it this way. So that's interesting. This one has how many forces on it? Two forces. One pushing what? This way, and one pushing this way. So if two forces are opposite each other, is there a potential chance that this could be what? Zero, that this effect on this one could be zeroed out? What do you think? Again, we don't know the numbers, but is there a chance? There is. Okay. Now let's put it here. Okay, let's run the same analysis. How would this one be affected by this one? Move this way or that way? Move this way because it's what? It's attracted. Okay. Now let's imagine this one doesn't exist and do this one and this one. How would this one move under the effect of that positive Q? Which way? To the what? To the right. Again, how many forces does it have on it? Two. And are they together or opposite each other? Opposite, because this one is going to pull it this way, but this one is going to push it that way or act on it this way. So is there a potential chance that it could be completely static here? Okay, there is, but it's impossible. Why do you think that is? So basically, I'm saying what I just told you. One vector goes this way, one vector goes this way. So potentially, there's a chance that this one will just stay still. But I'm also telling you that's physically impossible. Who thinks they know why that can't happen, even though the vectors are pointing against each other? Wadah, go for it. Say again. The particles are not stopped? What do you mean? Oh, they are, by the way, those particles are stopped. They are fixed in place because you can only move how many things at a time? One test charge only, which is in my hand. I am saying this test charge, if placed here, no way it's going to stay still. It's going to move. Why? Josh? Which one is stronger electric field? This one or that one? This one is stronger. Also, which one is closer to this one? That one or that one? Do you see what I mean? This one is both stronger and what? Closer. So which one definitely is going to win more dominance over this one? That or that? Exact. Do you see what I mean? So theoretically, you might say, but the vectors are pointing against each other. They are. But this one will have more influence than that one for sure. Making sense so far? Okay. By the way, I'm teaching you this because in university, so many of the questions would always be part A, where do you put it to cancel, like in which range, and then where exactly is the magic spot to cancel. So you, before you actually work out the math, you have to know the logic of which ones work and which ones no way work. Could it ever be static here? Give it a thought for 30 seconds. Could this ever stay still if it's placed anywhere in between the distance? Ammar, what do you think? Yes or no? Okay. By the way, you are cluing in on a good logical trick. Keep going. Oh, so it needs to be closer to it. Hold on. You said something about pushing. Oh, it's positive, regardless of the number. We just need the sign. Is there? Okay, so Ammar is cluing in on this one needs to affect this more than this one. I agree. But my question even was, would it ever be static here? Why not? How is this one going to push this one? That way. How is this one going to pull on this one? That way. Is it ever going to balance in this range? Negative, positive. It will pull it this way. Positive, positive is push it this way. Do you see what I mean? If you put it anywhere here and you leave it, it's definitely going to move which way? Definitely to the what? So out of these three, how many people have heard the word interval? Where do you hear the word interval? In which course? In math, exactly. So we have three intervals. Which interval is the only one with the possibility of this one staying still? Interval 1 or 2 or 3? Exactly. So they already told it to you. But on some of my questions, I might ask you, where do you have to place it first? Okay. So the question is, it's placed here. The total electric force is 0. The charges are separated by exactly 1 meter. The question is, where is the sweet spot? Where is the magic spot? Because there's a spot where if you move this way, or what, move this way, it might actually be moving this way or this way. There's a spot here that if you just put and let go, what's going to happen? What's going to happen? Hello. What's up? Do you want that? I have. Yeah. Oh, no worries. Yeah. Trust me. There you go. Tell her she can take as long as she likes. Okay, thank you. No problem. Okay. So, okay. So, do we know exactly where we're going to place it? Right now, do we know where? Can we generically place it somewhere? Great. So, along this line, who cares about realistically or not? Just put it in any spot on this line. Okay. So, I'm going to choose. Oh, my bad. Sorry. Okay. So, let's actually, everyone, choose it to put it right here. Come on. Go ahead. Put an X right there. Come on. Oh, so everyone, on your next slide, sketch the line again. Sketch the line again. Yeah, here. Oh, if you, just to give yourself more space here. Okay. Now, what charge are we going to put at that spot? But what did the question call it? Q3. Okay, everyone. So we'll go ahead and put Q3. Let's put it here. Q3. And we said that test charges are by default what sign? Positive. By the way, one of the reasons is to make the math easier. That's it. There's another physical reason you will know next week. Okay, so Q3, and we're going to make it what? A positive sphere. Right there. Okay, so how is this one going to act on this one? Which way? Right or left? That's positive, by the way. I'm just going to make it positive like this. Which way? To the left. So now I'm going to put a vector going this way and call it what? We can call it F plus Q on Q3, but all of them are acting on what anyway? Q3. They only act on one. So there's no need to say what they act on. you need to tell me what is the actor. So go ahead and like this, an F of plus Q. Okay, got that done. How about if we imagine this one doesn't exist, and how does this one how is this one influenced by this one? Thank you. Okay. By the way, do we know the distance between, let's say, Q and Q3? Do we know it right now? When you don't know something in math or physics, what do you just call it? X. Thank you. So let's actually, what everyone, since we do not know what this distance is and we need to solve for it, go ahead and label this as X. Nice. Okay. We said that this Q3 needs to stay what? Needs to stay stationary. Stationary means Newton's first or second law. So if something is stationary, what can you say about all the forces on it, especially if there are only two forces on it? They have to be opposite in direction, but what in magnitude? Great. So we know now that F plus Q. Oh, yes. Hello.
Just calling for attendance, please.
Yes. Just give me a couple of minutes.
Okay.
Okay. We need to know, or we state that the force of plus Q at that spot, which we don't know yet, but we're about to find out, must equal also the effect of F minus 2Q at the what? At the same spot. So we can what? Start by just saying F plus Q. You can say at X. You don't need to say that, but let's just say it for come on. There we go. At X must equal F negative 2Q also at X. Okay. Do we have an equation for the electric force between two charges? What is it? Yep, from the. What does it start with? Remember, it's like the gravitational force equation. K. So K. Okay, Q1 and Q2. In this case, what's Q1 and Q2? Q1 is just what? Q. And Q2 is what? Q3. All right, so go ahead. Q times Q3 divided by what? How far is the distance from Q to Q3? X, but it has to be what? Has to be squared. Good. Are there any cosines or sines here? Nope. Perfectly 1D problem. No angles involved. Equals K. What are my charges now? Hold on. Do we use the negative? Do you remember what we said about this equation? Do we ever use the sign? We don't. Why? Because we already used the signs to indicate what? The direction. We've already worked out the effect of the sign. So this is called a what? A magnitude equation. So it's 2Q times what also? Q3. They all affect the same test charge. How far is Q3 from 2Q all the way on the right? Raise your hand if you know the answer. How far is the distance from there all the way to the golden sphere minus 2Q? Muhammad. Exactly. So 1 plus what? Just 1 plus? 1 plus x, because all of them are in meters. So, but it needs to be what? Needs to be squared. So 1 plus x squared. And now we can simplify the math. Can someone tell me how the math simplifies here? I mean, definitely there are some things that could cancel out because they're common to both terms or to both sides. What cancels? The k's. What else? You see why they love not giving you values? Because they want to test your algebra. K's cancel out. What else cancels out? Q's cancel out. What else cancels out? Uh, hold on. X is at the denominator and being added. You cannot touch it. You only touch things when they're multiplied. So what are the only three things that cancel? K, Q, Q3. All right? Does anyone have any comment about what I wrote in the denominator for the second one? Yes, Noura. By the way, I did not say a thing. I made a mistake on purpose here because it's so common that people do it. And I made it. Noura, what is so bad about the way I wrote this? Go. I have to put what? It's not 1 plus x squared. It's 1 plus x all what? Exactly. It's the full distance squared. Here, which part of the distance only got squared? The x part. But you're supposed to square the what? So where should I put my brackets? Uh-huh. Put it exactly. Trust me, everyone, if you try to solve it the first way, completely either the wrong answer or you gotta get yourself a negative distance, which makes no sense because that's by default is a physical separation between 2 points in space. All right, now let's actually do that. Do the cancellations. So we said that k cancels with the k, q cancels with the q, q3 cancels with the q3. Nice. So what survives? Can someone tell me what survives on the left-hand side? Remember, anything that cancels, you don't get what? You don't get 0. You get what? You get 1. The biggest mistakes, people think cancel means 0. No, cancel means it got divided by itself, which means you got 1. So what survives or what remains on the left-hand side? 1 over x squared equals. What survives on the top? The q's got. Oh, first of all, no negatives, remember? No signs. It's 2q, but I only divided the q out. So what just remains? So yeah, so 1, 1, 1 times what? Times, oh, by the way, oh, sorry. It might seem like I crossed the whole 2q. My bad. Maybe that's why some people are getting confused. Sorry. The only thing that got canceled is just the what? Just the q letter itself. Sorry. Yeah, my bad. Sorry. There we go. Thank you. Awesome. So 2 over what? How do you solve this? By the way, there are 2 ways. A longer way and a shorter way. Who can tell me the longer way? Who can tell me the longer way? Ahmed, go ahead. Cross multiply. But you still have to do what to this bracket? What do you call it when you kill a bracket? No, E, expand. Simplify is when you clean up the bracket, when you collect like terms. I can do that. But I can do something also to simplify my life. Yes, if you crisscross and expand, you're still going to have to solve a what? A quadratic equation. I'm not saying you can't. But is there a square here? Is there a square here? Can you square root a square? Yeah, what do you get? You get the thing itself. Now, what if someone says, no, you can't, because 2 doesn't have a square root? Does 2 not have a square root? It does. Do we really care that it's not a perfect square root? No. But many students are so fixated on what? If it's not 1 or 4 or 9 or 25 or 16, you cannot what? You cannot square root it. You can square root anything you want. It's physics, even in math. So can we square root everything in here? Let's do that. What's the square root of 1? Square root of x squared. Just x. Square root of this guy. Just 1 plus x without the bracket. Square root of this guy. Square root of 2, which is 1.414 from trigonometry. All right. So let's go to the next slide. Okay, so square root, you get 1 over x equals 1.414 over 1 plus x. Now what do? Now you're done. Cross multiply. Sorry, cross multiply. And just we do what we've been doing for about 15 weeks. So I think I'm going to put these 2 on the left-hand side, 1 plus x, equaling 1.414 x. What moves to the other side? This guy. So you get 1 equals 1.414 x's minus 1x, which means 1 equals What's 1 minus 1? Well, you will only get the decimal part. So 0.414 x's, which means x equals 1 over 0.414. How much is that? It's slightly over 2. Slightly. Because if you divide by half, you would get 2 exactly. So if you divide by lower, you get a higher number. 2 point what? By the way, what's the sig fig situation for this problem? Now, you might think the 2q is only how many sig figs? 2q. 1. That's actually not in the sig figs because that's a counter multiple. Like you're telling me how many times is this charge bigger than this charge. What's the only sig fig do we have in this problem? The 1.000, which is how many sig figs? Technically 4. All right. What is your answer to 4 sig fig? Which is probably the biggest we've ever done. 2 point what? 4, 1, 5. In what standard units? Well, I mean, we already had it in meters, and we did not bother to change anything. There we go. What does that mean? If you place the what? If you place the test charge at 2.415 from the left side or on the left side of the plus Q, and you leave it, you are guaranteed that once you leave it, both forces will be equal and it will never move forever, unless you nudge it a little bit, because then you introduce some change to the system. Okay? By the way, those cancellation problem or cancellation point problems are very common in first year physics. And I will do a few more with you next week when we do the university problem. They're very common, not just in 1D, but also in what? In 2D. Yeah, they give you a bunch of charges on a square, and they tell you where should you put a test charge such that if you let go, it stays still. Okay. Again, it becomes just a 2D geometry problem. Okay, with vector breakdown.